Hello everyone, welcome to the class. So we will use chat box to communicate with each other, and whatever question which will be there you will answer in your chat box and we'll keep answering. So let me introduce you to the course a little. So right now we are majorly we will be covering around 200 MCQs which are specifically pertain to the research and statistics portion. I've also included few questions which are related to testing and measurements because they were quite synonymous and there were not a lot of questions from testing as such. There were majorly questions on reliability, validity, etc. But there were a lot of questions in regard to research and statistics. So on a daily basis we'll be doing roughly around 25 to 35 questions, and we'll be covering our syllabus like that. And we are going to cover last 6 to 7 years CUET. CUET was there for 2022, CUET PG, and we are going to do DUET papers as well, and we are going to cover all the research, statistics and testing portion. I've also used few other books which were there for GRE or GATE preparation because the level is very much similar. So we'll be doing all of those things along with that as well. So let us make these 5 upcoming days fruitful and make full use out of it. So let us get straight into our first question. You can start typing in. So which of the following can help control for experimenter bias? Double blinding, randomly assigning subjects to different groups, using control group, demand characteristics, or ANOVA? This is a GRE level question. Yes. Okay, you can keep answering. Okay, so few of you have answered double blinding and some of you have answered using control group. Okay, let us understand what does it say. The question asks, how can we control the experimenter bias, which means the bias which comes from the experimenter, and how is it given? It is given in the forms of verbal, not really verbal cues, non-verbal cues and gestures. So the experimenter should not really know which person belongs to the experimenter group or which person belongs to the control group, right? So we can use double blinding where the participant and the subject both have no clue about it. We cannot always randomly assign subjects to the group because maybe the experimenter group needs to be given an maybe intervention, and there are few characteristic or criterion. So always we cannot do that. We will make use of the control group, but if the person knows who are in the control or who are in the experimenter group, there would be some kind of expectancy effect. Then it has nothing to do with the demand characteristic. Demand characteristic has to do with our participant. It is a participant expectancy effect. The participant starts to behave in a certain way which the participant feels is desired by him or her. Then ANOVA is a testing measure, it will not be used. So double blinding is our answer here. And I have also attached in the notes in regard to various expectancy or various biases which are there. Okay, so you can give it a read. And we discussed about experimental bias already. Then we discussed about demand characteristic. Demand characteristic mein what is desired or what is expected out of the subject. so we can use some sort of deception. Then placebo effect, we know what is placebo effect, such as there was some person who I gave a medicine, and the like one group which I gave a medicine X to, and the other group which I just gave a sugar pill. So those who were given sugar pill still had some kind of effect on them, so it is also a type of demand characteristic. Then Hawthorne effect. The Hawthorne effect was a very unique study, and it is really prevalent, or it is really famous in terms of the HR and OB. So what was it? When the workers were being observed, their behavior actually changed. They were at their best behavior. So that is Hawthorne effect. And what can be done? We can obviously use control groups. So that was it for our first question, which was related to the expectancy effect. That is a major part of our testing. Now the second question asks you guys to calculate the mean. Take your time, give it 2 minutes, try solve it, and we can start answering in the chat box. Okay. Okay, well done. Well done. Most of you have answered correctly. It was simple. We will just sum all the observations which are there, and we'll divide it with the number of observations. So we'll do 1 plus 1 plus 7 plus 8 plus 8, and we'll divide it with 5, which would be, this would be 25, this would be 5, which would give us 5 in the end. So yes, that was our answer. In your entrances, let it be your GATE exam, NET exam, or your CUET exam, you will be given very simple questions in regard to calculating the mean and median, so don't get so much involved in it. You can just look through the formulas which are there, like for example summation of or whatever it is there, which is very much similar to this only. So I have also included few notes here for you. So how can you calculate the mean? We just did the mean, we just calculated the mean. Then what is median? Median is the midpoint. So if there are odd number, then the mid number would be the median, but if there are two numbers in the middle, we will add them and we'll divide them by 2, and whatever the answer would be our median. Mode is the repeated frequency, most occurring frequency or number which was there. And range is the difference between the highest data point and the lowest data point which was there. Okay, then good to go. Okay, any query? Okay. That does not really matter. So for example, if there are two 7s here, it does not really matter. 7 is the highest frequency. It has a it has a say, or it has a effect on the mode, but no, nothing on the range. We'll just take the highest frequency and the lowest frequency, which is lowest number which is there, lowest data point which is there, and then we would be good to go. So that was about our question. Now moving ahead further, I'm trying to change my slide, just give me a moment. Okay, so I hope The slide has changed now, has it? Okay. Okay, so you all of you can read the question and then we'll try answer. Okay. Okay. So here our answer would be A, not E. Why is it? We are asked about the correlation coefficient, right? So how, like, what does it range from? It ranges from -1 to +1. It cannot be more than minus or +1. So the E option is just incorrect, totally incorrect. So A would be our answer here. Okay, very well done to those who answered it. Very well done. Brownie points to you guys. Okay, moving ahead to the next question. We know what is correlational coefficient. Our R value, Pearson R that we calculate. Yeah, right. Okay. Those who are there in our research and statistics batch, you guys can also, what can you do? You can revise through the notes. I'm not asking you to go through all the classes because it's almost like 18 hours around. Don't go through all the classes, but just go through all the PDFs which were provided to you. It will benefit you a lot. Okay, then the next question. Give it a read and then we'll try answer. Okay, you guys can start typing in. Okay, then let us read the question. You guys can answer. So the question says that if a distribution has a lot of variability, which means we are not looking at our central tendencies, we are looking at our dispersions, we are looking at that. So if a distribution has a lot of variability, which of the following is true? Lot of variability. So the first question says that the variance will be relatively small. No, it will be high, right? Variance is what? Variance is the difference. Variance is the deviation. For example, if I create this one NPC or normal probability curve, we have a lot of standard deviation, which varies, which shows us the variability, which shows us the dispersion of the whole data. So variance should be higher if there is a lot of variability. Right? Variance is what? Variance is just the square of our standard deviation. Right? So mean will be relatively high. No. Variance has nothing to do with the mean. Though mean will be helpful in calculating the standard deviation, but standard deviation is calculated keeping in mind that this is our mean. That's incorrect. Then the standard deviation will be relatively small. We just said that variance is the square of standard deviation. How can it be small? No, it should be large. then the distribution will be skewed. Okay, we know that there is positive skewness, negative skewness, but it will have no effect on the deviation. There might be extreme cases. For example, there might be a lot of cases who have high score or who have a lot of low extreme scores, but then it will have no impact on our standard on our variability or standard deviation as per se. Then we have last option, which is the standard deviation will be relatively high. It seems like a correct option, because if the standard deviation is high, if we are going to square it up, then it is going to increase the variance which is there. So the correct option here is E. Okay, there is a comment. Okay, let me read. Okay, so these questions are from GRE books which are there, right? I will tell you. So from first to fifth questions are from GRE books. This question was also from GRE books which were there. Okay, the next question is a little lengthy question. Give it a little more time. Try solving it. Should I read the question with you guys? Okay, let us look at it. A researcher is interested in the effect exercise has on their spatial frequency. So, effect of exercise on spatial frequency. Now it is a very simple question, one question, but if you are appearing for NET, for example, then you have paragraph based question which are very lengthy, so you start to solve the question in your own way initially only. So exercise here is our independent variable. You can start doing that, right? Okay, then dV would be spatial frequency perception of the people who are suffering with Uthoff symptom. Okay, so the researcher takes 30 people and divide them into two groups. So 15 people are there in each group. So there are two groups. Let us name them group A and group B. It has 15 participants. The other group also has 15 participants. Then one group is told to exercise for 15 minutes. So they'll do exercise for 15 minutes, and the other group would do rest for 15 minutes. When 15 minutes are up, then each subject is presented with two pictures of the same object, one blurry and one clear. Okay, so they have to see two pictures which are there, and one is blurry and the other one is clear. So this one is blurry, the other one is clear, and they have to tell us that these two pictures are metamers or no. So which of the test will be applied here? Give it a try. Metamers. So metamers are those what do we say, those images that we are not able to distinguish between from. Okay, for example, when we lie those picture in front of our eyes, we are not able to distinguish from the, you know, like what is there in that image basically. Like that's not of our concern. Okay, so here chi-square test will be used. Why chi-square? Chi-square test will be used because they are both categorical in nature. There is no continuous data. We have two categorical data. First, our like this effect of exercise data is also categorical, discretely categorical. Then the effect, the dV is also measured in a categorical way, which was metamers or not metamers. So these type of tests are chi-square test. What do we see in the chi-square test? We see our expected score and our obtained score. Let us understand it on the next page. So what is there in, for example, this is a chi-square test and we have two groups here. One people who did exercise and others who rested. Okay, then they have to tell metamers or not metamers. So firstly we will have an expectation. हम बोलेंगे, शायद ये बोलेंगे कि it is not a metamers or it is a metamers, whatever, हम point कुछ भी allot कर देते हैं. ठीक है, जैसे 15 participant थे, so 7 said not 7 said metamers, 8 said not metamers. Here in 8 said ये and 7 said not metamers. This is our expected score. ठीक है, for example before elections what do? We do exit polls, right? कि how much each person would be getting, whatever. These are just expectation. Now for example I have my real scores with me. ठीक है, so for example the score came out to be, I am writing the actual score here in this box. So actually the score was 10, 5, then 10 and 5. So now we'll have to deduct it 7 minus 10, 10 minus ye. So in chi-square test, which is also denoted by this particular sign, we deduct our expected score from our observed score and so on. I think that's the formula. Is it observed minus expected? Yeah, it is observed minus expected. Thank you so much for pointing out. Thank you. So it is our observed score 10 minus 7. I'm so sorry. Thank you so much. Okay, so here I did 10 minus 8. Okay, let it be. So observed minus our expected score, whole square of it, and our expected scores which were there. So chi-square ke we have two identification. Firstly, there would both the variables would be categorical in nature. Okay, and we make or we compare our expected values or expected frequencies with our observed frequencies. Okay, so there are other tests also. When do we use different tests? So for example, when we have two different groups, so here also we had two different groups, right? But they were discrete in nature. They were artificially dichotomous. There was no actual group. They were artificially placed just like that, right? So here should be what? The data should be continuous in nature. It should not be categorical. It should be continuous in nature. It should, for using any kind of parametric test, how our data should be? It should be in interval measurement or ratio. ठीक है. And for using any kind of non-parametric, we will be using what? We will be having what scales of measurement? We will be having nominal or ordinal. So here we can see that chi-square test is used when individual observations are the names or the categories. Just that. So we are good to go. To our next question. Let's be a little quick in answering now. Now we have shorter questions only, and I think from here the questions start from the PYQ है ये. It is from the 2020 CUET. ठीक है. So I will mark when the test would change. ठीक है. So you can give it a read. Try to answer it a little quicker. Of the following are true for positively skewed distribution? We know what is positively skewed. We know the skew is for the tail. So if a test is positively skewed, which means the tail would be like this and would look somewhat like this. Okay, this is the positive side, this is the negative side. So it is skewed to the right. Most of the cases pile up on the left hand side. Yes, we can see that. It is skewed to the left. Okay, tell me, is it skewed to the right or is it skewed to the left? No, it's skewed to the right. We just discussed skew means this particular area, the lower area, the tail area. Okay, so it's skewed to the right. It is positively skewed distribution, so it's skewed to the right. Then most of the cases pile up on it. No, they are just contradictory to each other. So what would be the answer? The answer would be the options A and B. So 1 is our correct answer here. I have also attached few notes for you guys. We have different types of like our skewnesses, positive, negative and all. I'm not going to get a lot into depth. I think there is a free class on my YouTube also in regard to the skewness. You can check it out, I think. And for the batch, for the people who weren't there in the research batch, we did it in our class, so you can go through that class again or that particular part again. So skewness basically refers to the tail of area. Okay, so we have three types of curves. We have positively skewed curve, negatively skewed curve and symmetrical distribution. Okay, so we can see in the positively skewed curve, our mode will be the higher. Here the frequencies are there to the left hand side. Then this will be our median and this will be our mean. Same here, we can see that. Okay, if you have any query, kindly ask. Okay, yeah, it was a easier question comparatively. Look, most of the questions were repetitive. Even when I was going through the the previous year papers, there were a lot of questions which were there from reliability, validity, like a lot of them questions. So I would definitely want you guys to revise both of them. And in reliability, please revise the alternate forms, Spearman, Brown, and those split half formulas, Kudder, Richardson, all the formulas. Please revise this, and the validities also, because they are definitely going to be asked. Chalo, let's move to this particular question. Give it a read and then we would answer. Okay. Okay, very well done. Okay, so let us read the question till the time others can also answer. Okay. So statement 1 says that the value of product movement correlation. Product movement correlation is nothing but our Pearson correlation. Then it can be more than 1 in some. No, we just discussed it would be from -1 to +1. Look, the questions are from the similar background. So we need to be clear with our theoretical or our basic concepts, right? So it would be between, so statement 1 is false. Then even significant correlation does not tell us about causal relationship. We are just looking at the correlation, how both of them are related to each other. There is no IV or DV, there is no cause and effect. So obviously this statement is correct, that even significant correlation does not tell us about the causal relationship which is there. Okay, so what would be our answer here? Our answer would be statement 1 is false and statement 2 is true. Then moving ahead to the next question. If you guys have any query, you can type it in the chat box. I'll try to be a little quick, because I think it has already been more than almost half an hour has been there, and we are just done with 7 questions, and we have to do almost 25 questions, so we need to buckle up a little, right? Okay. Read the question, please. Okay. Okay, so the question was pretty simple. The question asked about which of these following are represented by the Greek alphabet row. The questions are interlinked. Look, we have discussed about it before also, and a lot of you have answered correctly, which is great. So Pearson movement, product movement correlation was denoted by R, correlation coefficient. Chi-square by this side, not like these brackets would not be there. Then we have a Spearman row correlation, which is a non-parametric correlation and when it is used with monotonic relationships. So Spearman row is there, it is denoted like this. Okay, pretty simple question. Moving on to the next question. Please read the question and answer. Okay, very well done. All of you have answered correctly. Here the correct option would be 3. Right? Plus minus sign does not really matter. Plus suggests what kind of relationship? Direct relationship or positive relationship, which means if one variable increases, the other also increases. If one decreases, the other also decreases. And negative just tells us that there is an inverse relationship or negative relationship, which means if one variable would increase, the other variable would decrease. Simple. So minus 0.90 is the correct answer here. It is explaining the maximum variance. Okay, then moving ahead to the next question. Very simple question. Yeah, they were all there in CUET 23, 22. Yeah. Okay. I checked out CUET 23 question sample paper which was there. There were 30 questions, I guess, but there was no question of research and statistics, so I did not really included it because there were not any. So we'll do more GRE based or gate based questions because they are of the same level. So okay, let's move to the next question. Please give it a read. Please read it nicely. Okay, so you are saying you find assertion reason question a little difficult. Let us see how we can solve it. We'll solve it. Others can answer. Look, I don't know, the people who are looking at the recordings, please make sure that you are pausing for a minute and then getting ahead with the question, right? Don't just jump to the answers. Solve it yourself and then means. Let us read. Okay, so the assertion says that normal distribution curve, our NPC, normal probability curve, when we plot it, this is how we plot it, it never touches the x-axis. This is our x-axis. It never touches the x-axis. Then we'll add y here. Okay, why does it not touch the x-axis? Because the range of normal distribution is from negative infinity to positive infinity. Though it is theoretical only, in practical aspect there is -3 to +3 which is only possible, but in theoretical terms there is this. So if there is negative infinity and negative, so it will never touch the x-axis when we plot it. So A and R both are correct, and R is the correct explanation of A. So 1 is our answer here. Yeah, there are a lot of variety of the questions which are there, but most of them are basics. They're not of high difficulty. They are very, very basic. Okay. Yeah, like I don't know, like I think it will help you also if you will try to include y and then you will be like, okay, because this is the reason. Try to do it this way. Maybe it will help you. Yeah. Okay. Okay then. This is a reliability based question. This is a matching. Give it a moment. Think about it. Match it and then we'll discuss the answer. here. Okay, let us read the question. All of you can answer. Yeah. Split half reliability. What is split half reliability? Reliability is what? Reliability is consistency of scores. It is really important. For example, I have made a inventory for depression and I am testing it on a population. If I test the same inventory on this population after a duration of time or after a while, then they should fetch similar score. Now the condition should be that there was no change, there was no intervention which was given, etc. So there should be consistency of scores, which makes the scale or this particular inventory reliable. What is split half reliability? There would be one form first of all in split half reliability, which we will be splitting in half. Now it can be splitted in two ways. Either we can make a odd even distribution, such as all the odd numbers we'll take together an even number and then we'll see the consistency of scores. Or it can be done in terms of first half or second half. Right? Then alternate form. Alternate form is also known as parallel form reliability. And we have immediate and delayed. Immediate means that, for example, I have given you two forms here and I have asked you to solve, or I have asked you to, like whatever, do whatever the instruction was on the same time. And delayed, there was a time difference, there was a time gaps. Parallel forms are there, such as you must have seen that, like for Quartiles culture fair test, there was form A, form B, etc. So there are parallel or alternate forms which are created. Okay, so then at last we have test retest reliability. Test retest reliability is very much similar to this example that we understood, that there would be the test, we'll conduct the test and then after a point of time we'll conduct the test again. Okay, so now let us see. In split half there was one form. Okay, and in split half एक ही बारी testing is required because we are splitting it anyway. So split half would be 1. A is 1. B, alternate form. Alternate form matlab where there would be two forms, parallel forms, and they are given immediate. Matlab in one session there are two forms. In one session there are two forms. So B is going to be 4, 2. Then alternate form. Alternate form there are going to be 2. And herein there is going to be a delay, which means we have to conduct it in 2 sessions. So our C is going to be 4. Then we have test retest. I'm sorry, there is a voice in the background. Just give it a moment. There was some vehicle which is passing by. Just give it a moment. Okay, yeah. Am I clearly audible now? Okay then, thank you so much. Okay, let's move forward. So test retest is what? We are conducting the same form. One form is going to be there in 2 sessions. So D is going to be 3. So A is 1, B is 2, C is 4, yeah, and D is 3, yeah. So 1 is our correct option here. It was really simple. It was a little logical, like you had to give it a little time, but it was easy, right? And even I would say for CUET exam, you have 120 minutes for 100 questions, which is a decent amount of time. Like there would be few questions where you can actually spare a little time. Like 1 minute would be enough for a lot of the questions which would be there. Like the theoretical question, these whatever questions we are doing right now are related to research, so it might seem like they are very time consuming and all, but the others would also be like theoretical base, or like they are related to a particular theory which are going to be solved just at that instant, right? So it is going to be fine. Then moving ahead, moving to the next question, just give it a read and then we would answer. Okay, it's not that a difficult question. Try solving it quicker. Okay. Okay, let's try solving this one. So here we are talking about z-score. People, those who were there in my research lecture, why were you not able to answer this? It was so simple. Only yeah. Okay, Riddhi. Yeah, it's that only. It's based on that percentile and everything. Yeah, it's that only. So this is our NPC. We read about that. There is a video on my YouTube channel for this also. Please go and watch it. I'm explaining to you in brief. So this is our mean, and our z-score would always be 0 on our mean. Our standard score would always be 0. Then we have 3 positive standard deviation and 3 negative standard deviation, and we have 34% in first standard deviation, 14 in second, 2 in last third standard deviation. So if we would add all of these together, it would be 50. So the z-score on our 50th percentile is going to be 0. So 2 is our answer. Yeah, simple, right? But it seemed a little difficult. Yeah, Spearman-Brown formula. Please give it a read. It is a very simple question. So the question asks about the Spearman-Brown formula. What does that Spearman-Brown formula explains? What does it talk about? Those of you who have learned about reliability, I hope all of you must have. It is a part of testing. So what did we learn? The batch was all about research and stats. We did not talk a lot about testing. So herein, when we talk about Spearman-Brown formula, we talk about what will happen if we double the number of items which are there, or we deduct the items by half or 1/4. What will happen to the reliability? That's what we discuss. So it is a relationship between the reliability and length of the test. So 4 is going to be our answer here. No, there is no relationship between reliability and validity in Spear-Brown. No internal reliability. Internal consistency reliability? No. Item total correlations? No. Richardson and all. We'll go through that. Like, you will have to go through that also. I think there are going to be questions on the same, then we'll discuss about that also. So the question is also about reliability. Please give it a read. It is a statement based question. Please try to answer a little quicker. Yeah. Okay, it was fairly simple question. Reliability refers to the consistency of scores. Correct. When a test is reliable, it has to be valid. Not always. Not always. Because for example, I made up this particular test. Okay, random questions. There were random questions which were there. And I conducted this question over a period of time. Then there was consistency, split half, all those. There was reliability. There was consistency of score. But it is not measuring what it intends to measure. It does not have any content validity. There is no construct validity at all. So it is not necessary when a test is reliable, it will be valid. Right? So our answer would be statement 1 is true and statement 2 is false. So 3 is the correct answer. These are all CUET 23. Like, look, there are quite a lot of questions which are there. Almost 10 questions are there from research part. Okay, yeah. This is on the basis of scales of measurement. We did it in our class also, research class. Please try to solve it. Yeah, I think I can do that. I can upload maybe unfilled copy of these formulas, of these questions, and then I can upload this answer key wala question. Is this what everyone wants? Tell me, I'll do that. I'll keep that. Okay. Yeah, actually you can do that after we are done, and like at the end of the day you can just go through all these questions and you can try solving it for yourself. Yeah, that would be nice. Okay. Okay, yeah. Okay. Okay, let us. I'm sorry. Yeah, let us read our question. Okay. Nominal scale, wherein the data that we have, it will just for our namesake or for our category, just for identification. For example, I have given 1, 2, 3 to someone just like that, just to differentiate between them, just to identify them. So nominal scale would be fourth, can be used to identify person and object. Then about the ordinal scale, what is going to be there in regard to ordinal scale? Ordinal is ranking based scale. Which of the which of the options here talks about that? Third one, that there is going to be a difference in successive unit of measurements and is presumably unequal. There is successive unit which is there in ranking, like first, second, third, and there is going to be difference in measurement, and it's ordinal. So okay, so our A was 4, our B was what? Our B was 3, yeah, third. Okay. C, interval scale. Interval scale is what? Interval scale is when we have we do not have a absolute zero. For example, I have 5, 10, 15, or temperature, you can say. Temperature can be there on a continuous level. It can be there, it can be expressed in terms of decimal also, but there cannot be no, like we cannot say if there is 0 temperature then there is no temperature. It is also some temperature, 0 degrees Celsius, right? So it does not have a absolute zero, it just has a reference zero for us to refer to. Okay, then moving ahead, we have ratio scale. Okay, so C was what? C was reference zero, which was 2, and D would be ratio scale. It would have a absolute zero, like 0 centimeter. There is, which means there is no height at all. So A4, B3, C2, D1. So 3 is going to be our answer. Right. Okay, then moving ahead with the next question. I think from now the question starts from DUET 21. So all the questions which are going to be there from now onwards are going to be from DUET 21. These are all the questions which were there in CUET till now, whatever we have discussed. Okay, so give it a moment, think about it, and then we will discuss. Okay, I am going to give you all a hint. There is a trick here. There are 2 options which are correct. Okay. Okay, let us look at it. So the question says, let me add another slide, about quartile. Quartile means 1/4, which is what, 25%. So for example, this is the whole data set. So this is the 25%, then 25%, then 25%, and then again 25%. So this is going to be the first quartile, second quartile, third quartile. So the difference between the first quartile and the third quartile is known as interquartile difference. But here there is a twist. The question asks half the distance between the first and the third quartile. So what will be the formula here? It will be Q1 minus Q3 upon 2, which is a formula for quartile deviation, which is also known as semi-quartile range. So the difference between Q1 and Q3 quartile, the first and the third quartile, is known as interquartile range. But if we divide it into half, then it is known as standard quartile deviation and semi-quartile range. So here our answers were 1 and 3 both. Even in the key later it was rectified, it was both 1 and 3. In this paper there were quite a lot of questions which were like that, where they had 2 answers in a single question. I don't know why would they do that. But anyways, let's solve the other question. 17th question, we have already talked about nominal ordinal. It's quite fairly simple. Try solving it, please. Okay, try to solve it. I can see few answers. Okay, we need some common sense to solve this question. Okay. Okay, lovely. I can see a lot of you who have answered, but what would be the correct answer here? The correct answer would be interval scale. Let us see how. Yeah, let us see how. When you get yourself tested via medical record, they have a specific value. For example, for hemoglobin or for any other value that you get yourself tested for, maybe cholesterol, blood pressure, blood sugar, etc. Right? So though we have a specific value, we are not just giving them tags just like that ki you are chronic, you are acute. No, it's not nominal, it's interval. Why? Because there would be a reference 0, there would not be absolute 0, so it cannot be a ratio scale. Then we have a specific value. For example, blood sugar above maybe 80 below is normal, not classified, whatever. Something above 150 is acute and something like 300 is chronic. I'm just giving an example, a rough hypothetical example. Okay? So it is based on interval scale, not on nominal scale. Okay? Then question number 18. Please give it a read and try to answer. This question also has 2 answers, which are just other names, just like that quartile deviation and semi-quartile story again. Yeah. Actually, initially I used to do a lot of quiz and all of these things for GATE exam. This is also my first time to do proper MCQ type thing on CUET, because 3 of you people were for like appearing for CUET PG, so it felt logical also, and a lot of you were there, like others were appearing for GATE and NET also. So GATE and NET has a normal level, they would be asked about paragraphs and all of those, but then these questions are a little like you would have to use logic, you would have to be, you know, brush, like your basic should be brushed up, so that's a good thing. Okay, let's give it a read. So the question asks, what is the area in sampling distribution where if the results falls within it, null hypothesis is considered false? So we have NPC, normal distribution curve, we have regions, क्रिटिकल रीजन्स, जैसे हम 0.5 लेते हैं, अगर टू टेल्स है तो यहाँ पे 0.25 होगा, यहाँ पे भी 0.25 होगा. We do it in two tail. This is what, this is region of rejection or critical region. कि our area, our this our effect area, this is our effect area is 95%, and there are 5% chance that our theory or our results can be wrong. So it is a region of rejection जहाँ पे हमारा rejection है, और critical region. So both are the answers here again. Okay, let's move on to the next question. Fairly simple one. Yes, actually I would say, I don't know why would they do that, because it's quite confusing. Like it's not a MSQ based, like you don't have to choose more answers. I don't know why they have done that, and but it's fine. Like already I would say students are a lot confused in the research and stats questions and all, and something like this is going to make them even more confused. Okay, give it a read. Okay, it is a fairly simple direct question. There is nothing, there's not a lot of things to think upon or solve upon. If you know, then you know. Okay, so the answer here is Kruskal-Wallis. Okay, so the answer here is Kruskal-Wallis test. I have also attached this one table for you to remember. You can be asked about other things also, as you were asked about one-way ANOVA. You can be asked about pair t-test का equivalent क्या है, which is Wilcoxon rank sum test. ठीक है, and then we have जिसको Mann-Whitney U-test भी बोलते हैं actually, unpaired t-test, Mann-Whitney U-test. Pearson correlation का non-parametric equivalent is Spearman correlation. Rho, we just did it. One-way ANOVA का Kruskal-Wallis test. I think on bachelor's level this is sufficient. You don't need to know a lot more depth into, like you do not need to know a lot of goodness of fit test and all. If they ask, I don't know, because when we were in our bachelor's, maybe I don't think so we were taught about goodness of fit tests. But anyway, let us just move forward with our next question. We are just left with five more questions. So be on it. Let's solve it quickly. I am also really tired from speaking from so long. Would you guys want to take a 5-minute break, or would you want to just wrap it all up and then take a break? Yeah. Okay, then let's wrap it up only, and then we would be taking a break all at once. Okay, so the next question is also on the basis of the validity, different type of validity which is there. Try to solve it. Look, Riddhi, if you have to solve these, you need to know the basics. Like if you don't know like what Spearman Brown is, you have not even heard of it, then it's a little problematic, right? Because we are practicing the other like MCQs. This is a MCQ batch only. I think you should enroll for the research batch and then learn there a lot first, and then you can maybe do these things again. Because for me personally, if I would start getting into depth of all these things, then it would be very difficult for me to cover more and more MCQs. Because in a day, if I'm able to only cover 25 MCQ, what am I doing? For the first day I kept it 25 because I wanted to keep it a little basic, a little easy on you guys also, because it's the first day, so 25 was enough for me. But then from tomorrow maybe we are going to have 30 to 35 questions. Depends on the question, depends upon the test that we are going to partake. I'm also taking it one day at a moment. So if it's a 5-day thing, like 25 to 30, 29 we are going to do it. So this is how it is going to be like. Okay, then a lot of you have answered, and most of you have answered correctly. It is a concurrent validity. It's not construct validity, it's a concurrent validity. Why? What are we doing here? It is not content validity, because it is clearly stating that we are correlating the test score. We are not looking that if the construct is correct, if it measures what it intends to measure, it has all this. No, it is saying directly that the scores are correlated with an external criterion or maybe external test which was already present at a given point of time, at the same point of time. If it would have been after a point of time in future, then it would have been predictive validity. Okay? कि one test can predict the scores on other, okay, and they are so much correlated. But herein at the given point, then it is a concurrent or current validity. Yeah. Okay, then let's read on the next question, please. Question number 21. Very simple question. Reliability, which can be estimated by having a sample of test graded by 2 or more examiners. There are different people grading if this particular test is reliable or not. It is what? It is inter-rater, inter-scorer reliability. 1 is our answer here. Very well done. Then question number 22. It is based on non-normal distribution. Yes, Riddhi, we have done these things, like all these basics and these these advanced topics in our batch also. So yeah, they're fake. Like a lot of videos on the basic concept are there on my YouTube channel, but then there are not a lot of videos on these. Firstly, I don't post a lot on my channel also, I would say. I've just resumed to do that. I don't know from how long I would be consistent, because it's quite a task for me. But then, yeah. Okay guys, it's almost going to be 1.5 hours. Please, let's just wrap it up. I thought these are way too less questions and we'll be done in like 1 hour or something, and okay guys, first answer, then we'll get on to the charts. Please answer first. Question number 22. Okay, let us look at it. This question has to do a lot with the kurtosis, has to do with kurtosis only. So we have 3 different types of kurtosis. We have platykurtic, leptokurtic and mesokurtic. Okay, so kurtosis is basically on the basis of the peak. Skewness was on the basis of the symmetry. Kurtosis is on the basis of peak. So it says that the punched in center में है ज़्यादा और peaked भी है. So it will look somewhat like this, कि center में ही ज़्यादा है, side में तो बहुत ही कम लोग हैं. So it is a leptokurtic distribution to leptokurtic. We also have mesokurtic, which is a normal distribution. Then we have a platykurtic, which has higher tail, जहाँ पे almost similar ही distribution होता है. There is not a peak. So it is a platykurtic, you can say, right? Okay, moving on to the second last question. Please give it a read. Okay, it's very simple. Look, here in the variables are pre-existing and they cannot be manipulated. ठीक है, and they are measured for differences or correlation. ठीक है, now it cannot be naturalistic. It can be, but we are not observing it right now. It's already pre-existing. Observational research भी नहीं है, time series भी नहीं है. It is a post facto research. The question was a little loopy, but then it's okay if we eliminate. Then last question. It also has 2 answers. So yeah, give it a read, please. Okay then, okay, let's discuss it. Okay, why are you guys saying normality? How can it be normality? Normal distribution, we have done it so many times. Normal distribution is simply that most of the people lie in the average. There are very few people who are scored very high or who have scored very low. Negative side, positive side, remember? That's normality, normal distribution. That's it. Here the question asks for homogeneity of variance, homogeneity of dispersion among treatment variables. For example, there were 2 treatment variables which were there. One was diet and the other was exercise. Okay? And the variances or the differences among these conditions were similar to each other, then it is known as homoscedasticity. Homoscedasticity is what? The errors would also be constant. If there is going to be an error which is going to be there, so it would be same in both the cases. And it can also be sphericity, because it can also be a repeated measures design, and in ANOVA repeated measures design, it showcases that the variance of both levels are going to be same. So 1 and 4 can be answered, and this was, I don't know, like in three or four questions there were 2 answers. So yeah, that was about DUET 21. So we have did 2 questions papers, 2 last year question papers. Today we have completed our CUET 22. We have also completed our DUET 21. We have also done few questions from the GRE books, right? So it was a good class. I really am happy that a lot of you participated in the class, and that's it from my end. If you guys have any queries, you may ask, and then we would wrap the class.